We talk a lot about Charon, Pluto's largest moon that is half the size of its host planet. But what about the other 4 smaller moons? They are interesting, to say the very least. Pluto's 4 smaller moons, Styx, Nix, Kerberos, and Hydra, are differently fascinating than Charon. These moons are each 20 to about 50 times smaller than Charon. They aren't round like Charon, and unlike pretty much every moon in the solar system, they are not in synchronous rotation with their host planet. They don't always show one face to their host. Instead, they are spinning incredibly fast. Hydra, for example, the most distant of the 4, spins 89 times for every orbit it makes around Pluto. New Horizons mission scientists suspect these chaotic spin rates could be due to Charon exerting a strong torque on the bodies that stops them from settling into a more common synchronous rotation. But that's not all. These small moons also wobble far more than scientists expect small moons to wobble. They behave like spinning tops more than anything else. This uncommon movement could be explained by observations that suggest these 4 moons were formed when multiple smaller moons merged, which means at some point in Pluto's history, likely in the aftermath of the theorized impact that formed Charon, the tiny planet had more than 5 moons, but the smaller moons coalesced into the ones we see today. And it's worth noting that these are Pluto's only moons. Mission scientists did expect to find more moons when New Horizons reached the Pluto system, more leftover debris from the impact, but found nothing. Pluto only has the 5 moons that we discovered from the Earth.
Well, hello everybody. This is Scott Roberts. And today it's just you and me. I wanted to tell you all about tonight's very special program. It is Clyde Tombaug's 115th birthday today. And so there's just this amazing group of people that are coming on tonight that will be covering all different aspects of Clyde Tombaugh, his discovery of the frozen world that had been searched for an extremely long time. And Clyde discovers that within his first year of using the new, what became called the Pluto camera and what is now called the Pluto Discovery Telescope. But I want to recognize some of the people that are on watching the show today. We've got Mike Wiesner. He says hello from mostly clear southern Arizona. He says he plans to image a magnitude 17.6 asteroid tonight, so that'll be very cool. James, the astrophotographer, says happy 115th birthday, Clyde. We've got Bergman Scooter on, Aaron Thompson, Richard Grace, Jeff Wise, Michael Whitaker, saying good evening, everybody. Cameron Gillis, hi all. I'm tied up now with work meetings, so I'll have to watch later. That's okay. Aaron Thompson says, wow, 17.6 magnitude asteroid. I'd like to know what you use to reach that. I think Mike's going to use his iPhone. Maybe not. Okay. Anyhow, the program, as I mentioned, is the idea of it was a brainstorm between myself and David Eicher at Astronomy magazine. He's the chief editor over there. He's on many of our shows, most of our global star parties right now. Today, he sent me this cosmic 3D clouds, and this was written between him and Queen's lead guitarist Brian May, who's also an astrophysicist. In this book, I've just had a few minutes to peek into it, but it has lots of these double images here, and they're processed so that when you look at both images at once and kind of cross your eyes a little bit, you can see an amazing 3D view. And so it's going to be a lot of fun to go through the book, and it's something I'm going to refer to again and again it's just really cool to see nebulosity and stars just kind of jump off the page like that. So thank you very much, David. I've been on the phones with various people that are connected with this, including Kevin Schindler, who's the official historian of Lowell Observatory. He's going to be inside the Pluto Discovery Telescope dome. So we're going to get a well-rounded experience and tour of that telescope that Clyde Tombaugh used as he came. I guess it was the first professional telescope he might have used coming right off the farm. He sent his drawings of Jupiter and I guess other planets that he had done, and Lowell hired him off right off the farm from those drawings. So I think that we're going to hear David Levy talk about Clyde. He was good friends with Clyde Tombaugh. Wrote his biography and has lots of firsthand accounts with him. And then we're going to roll right into the entire editorial staff of Astronomy magazine. And so I think you're going to love that. A lot of new members of their editorial staff that maybe a lot of people are not familiar with, but extremely knowledgeable people in their own right. And then we will also have Dr. Alan Stern from the New Horizons mission to Pluto, and then he'll also talk about the extended mission to the Kuiper Belt. Alan Stern will be doing a Q&A with David Levy and David Eicher. Leading into the rest of the program, we have astrophotographers. I know Molly Wakeling is going to be joining us. I believe Richard Grace, I think the Astro Beard might be there. And all of you that are watching this program are also invited. And what we're going to do is we're going to once again do the after party. And so I'll give you the link, the Zoom room link, where you can go and check your audio and video. You have to stay on topic. This is an astronomy program, so you want to stay on topic. But once you're all checked out, then we'll give you the link to the show, and you can show what's through your telescope or share your experience or anything to do with astronomy. We're all about it. So, but it all starts tonight at actually we'll probably start logging in about 6:30 p.m. Central. So there's kind of that behind the curtain banter that you'll hear, and then we'll get started live broadcasting at 7 p.m. Central. So we hope that you're going to watch. And let's see, do we have any comments here? I see a lot of you are going to watch it tonight, are hoping that you're free. We hope you are too. We're expecting a worldwide audience. We have also partnered up a little bit with cloudynights.com. The show will be broadcast on their homepage. You'll see it there, as well as Facebook, Twitch, Twitter. Mount Wilson's Facebook page is also going to be showing it. And I'm totally jazzed. I'm totally excited. This is something that is exciting to me. I think I have my star chart here somewhere that I can show you tonight, which has Clyde Tombaugh's signature on it. And I was able to meet Clyde once and got him to sign my Sky Atlas 2000 star chart. So that was really amazing. I also met Christy, who discovered the first moon that they discovered around Pluto, which was Charon. So it's wonderful to meet people like that have discovered other worlds, but it's also even better to explore it yourself. And so we'll talk all about Pluto. We'll talk about Clyde Tombaugh. We'll talk about other things as well as the Astronomy magazine editorial staff kind of goes through who they are and what they do and their presentation. So I think you're going to love it. And so I've got a little program coming up after this about the New Horizons mission that you can watch. I do encourage you to watch the Winter Star Party program, which will come up on February 8th through the 11th. We'll be broadcasting for 4 hours each day. So that's going to include not only Explore Scientific, but Celestron will be there. There'll be a lot of other companies presenting stuff. I think Teleview is presenting as well, which I think is great. There's going to be great talks from the historical people that started the Winter Star Party, and figures that that we all know and love, like Tippy Dioria and Michael Reynolds and Don Parker, and there'll be several others, plus new speakers that that had agreed to be on the Winter Star Party for the 2021 event. On Monday, we have Mr. Eclipse, I think, yeah, he's a doctor, Dr. Fred Espenak. And so Fred will be talking about his new book that is about celestial events happening this year and many years into the future. So anyhow, what else can I tell you? I'm going to give away, or we're going to give away, one of the Pluto globes that Astronomy magazine offers. I'm getting one for my own desk, but we decided to get one as well, just to give it away on the show. So the Astronomical League, with the president of the Astronomical League, Carol Orge, will be on with us to ask questions, and the winners will be able to get things from Explore Scientific, from our prize partners, and also this special Pluto globe. So I think you'll really love that. And I think that's all I have for you right now. We are busy shooting other videos still for the Winter Star Party. And it's going to be a great beginning of this year. So take care, and we will see you in just a few hours. Take care.
Once the science team had time to study the amazing images that were returned on July 14th and in the months to come, they were astonished to see that Pluto showed many examples of phenomena also seen on Earth: glaciers, volcanoes, mountains, and even blue skies. Soon they were engaged in looking at what seems similar and, many times, completely different.
Planetary scientists love to compare similar processes on different bodies. It's called comparative planetology. You compare the different experiments that nature has done.
We're all wired for comparative planetology. We can all look at one thing and it'll remind us of something that we've seen before.
We use what we know about the Earth to try to inform our knowledge and understanding of what's going on Pluto.
We see these analogs, but in completely different contexts on the Earth, and yet they behave the same way, but at vastly different conditions, and for materials that are vastly different from each other.
On Earth, we have glaciers that are made out of water ice. On Pluto, we have nitrogen ice glaciers. How do they differ? How are they similar?
The single biggest feature on Pluto's surface is a region that we call Sputnik Planitia, which is this giant sheet of nitrogen ice, frozen nitrogen ice.
This vast plain, smooth plain, had no craters whatsoever. It was gigantic. It's the size of Texas and Oklahoma combined.
It almost fills one hemisphere of Pluto and produces the left ventricle of that heart of Pluto.
We had no idea what we were looking at first. It took us a while to even develop some hypotheses of what this could possibly be.
Sputnik Planitia, I like to say, gives Pluto its mojo. It really is the source of almost everything that we see on Pluto. This giant sheet actually moves like a glacier.
That, to me, is such a favorite, because it's like, wow, that place is like, it's like here. You know, you see things that we see here on the Earth, but with materials that are completely different.
It's very much like a water ice glacier on the Earth. It flows, can flow around barriers.
The secret to Pluto's activity is that its surface is full of these very mobile, super cold ices, solid nitrogen, solid methane, solid carbon monoxide, and it doesn't take a lot of energy to make this stuff move.
The bonds that make nitrogen ice crystals are different than in water, so they're actually weaker.
Nitrogen ice is very soft. It has kind of the mechanical properties of a slightly stiffer version of silly putty.
But when you look in detail, you see that there are these giant sort of blisters that are separated by little sort of ridges. And these blisters are maybe 30, 50 kilometers across. They have the pattern of upwelling and downwelling material that's moving slowly like churning oatmeal on a stove.
The surface has all of these polygons on the top, and we think that they're convection cells. So what this is saying to us is that there's a heat difference between the top of that nitrogen ice and the bottom of the nitrogen ice.
The core and the mantle of Pluto have just enough radioactive material in it that slow decay of the radioactive material produces just enough heat to stir these extremely volatile ices, which are mobilized at only a few tens of degrees above absolute zero.
It's sort of like a lava lamp. You get the heating of the material in a lava lamp, these blobs go up, and when they cool, they come back down, and that's similar to what's happening to this nitrogen ice on Pluto. And what that means is that surface is relatively young, geologically speaking. And in fact, we had our highest resolution images cutting across Sputnik Planitia, so if there were craters there, we were going to see them, but we didn't detect any.
But to the south of Sputnik Planitia, there were two round shapes. These were too large to be craters. Even now, there's some uncertainty about exactly what they are. But once again, knowledge of what makes such shapes on Earth made many on the science team suspect they were seeing volcanoes, although volcanoes operating very differently from here on Earth.
Pluto revealed a lot of surprises. Those huge craggy peaks all around the edge of Sputnik Planitia were mind-blowing enough. But then to see another construct, another mountain in the southern end of Sputnik Planitia called Right Mons is even more mind-blowing because it doesn't have the same shape as those, and we need to have some other way to explain that object. This construct looks like unlike anything else on the surface of Pluto, and immediately got all the geologists thinking, I wonder if this is a volcano.
They're giant mounds, 100 miles across and a few miles high. These potential volcanoes on Pluto have some similarities to a shield volcano on Earth, like you might see in Hawaii. They're very big, broad mounds, but there's one major difference, and that is that they have huge central depressions, whereas the shield volcanoes on Earth have a tiny little caldera at the top relative to the size of the feature.
In 2018, Kilauea on the Big Island of Hawaii began a series of eruptions and lava flows that changed the landscape and made the observation deck close to the summit too dangerous for both tourists and scientists. We were one of the last film crews to work there.
We're here on the summit of Kilauea, in the Big Island of Hawaii. We're looking at a volcano on the Earth, which we know of as hot lava flowing up out of the ground. And that's what's making the red glow that you see, which is volcanism in action on the Earth. Volcanism is a process that happens on many solar system bodies. What you're talking about is a liquid that is at depth and it gets erupted onto the surface, cools, and freezes. So on the Earth, we're talking about rocks. Stuff that we're standing on here, as it's erupted, is incredibly hot and molten, flows out onto the surface, and then it takes on these shapes and forms that we see around us.
Some of the lumpy textures that we see on the flanks of the icy volcano are similar to the shapes of the Pohoihoi lava in Hawaii, except that they're much, much bigger.
Right Mons on Pluto is about 90 miles across and over 2 miles high. And that compares with Mauna Loa, about 70 miles across and again about 2 miles high.
These potential volcanoes on Pluto We think that instead of an explosive type of eruption like we might have on Earth, we have more of an oozing of material coming out, building up the mound over time. And this material is icy, but it can still flow. So if you imagine something like toothpaste flowing or ketchup flowing, it's solid, but it can still flow.
So here we are on the flanks of Kilauea. You see lava all around here. It's maybe 20 years old. The important lesson here is about time. When you get up close and look at this stuff, you can see here's this darker material, smoother material. It's all different. You can see one on top of the other. And this tells you that this construct formed over time. This is one of those central mysteries that we've got to understand about Pluto. There aren't any craters on right Mons. And that tells you immediately that something's happened. Something has resurfaced that area of Pluto. Just like this lava here has resurfaced the Earth and erased a road, in the case of Pluto, we would be erasing craters and show that it's a very young feature. Did Mons form in just one impulsive event in a very short period of time, or did it take millions of years to form? All we know right now is that it's very, very young.
And while the volcanoes remain mysterious, the spectacular mountain chains that dot the planet were more easily explained. What was perhaps most amazing was that these peaks were made not of rock, but frozen water ice, H2O.
The mountains of the Earth and Pluto can be compared. In many ways, they're similar, but in many ways, they're also different. One of the great differences is that on Pluto, those structures exist in a much lower gravity environment. Much more fragile structures can ascend to great heights, for example.
At the surface temperature of Pluto, ice is as hard as rock. So that's your bedrock, so to speak, is bed ice.
The nitrogen ice actually can buoy up giant blocks of water ice, forming mountains as high as the Rocky Mountains in the United States, sticking up like giant icebergs.
And sometimes they're snow-capped with other materials like nitrogen or methane, but they're constructionally made of water ice in enormous blocks that stretch 15,000 feet into the sky above Pluto's surface.
Mountains are really, really rare in the solar system. There are places that we call montes around the solar system, but for the most part, like on Mars, they're just lonely mountains out by themselves, big shield volcanoes. You don't get mountain ranges like we have on Earth because you don't have plate tectonics on these other planets. But you have something not quite plate tectonics, but that still moves chunks of material around like plate tectonics do on Pluto, and so you get these distinct mountain ranges on the margins of Sputnik.
Like Simon, many members of the New Horizons team work at the Southwest Research Institute in Boulder, Colorado, since that's where the mission's principal investigator, Alan Stern, is based.
A lot of the people in the room were from here, so I made the comment that, we sent a mission to Pluto, but it actually took pictures of Colorado, because when we first saw the Norgay Montes, it just so happens that first really high-resolution picture we saw of Pluto was of mountains.
Now, I'm a rock climber, and I love climbing up rocks. And so instead of climbing rocks, we would have to climb ice, up these big mountains of ice. But ice covered in brown, oily, gooey, gunky, yucky stuff that's rained out of the sky. Very bizarre and extremely difficult to climb.
As New Horizons departed the Pluto system, it looked back to Earth as radio waves were beamed up from NASA's Deep Space Network's largest dishes to the spacecraft, revealing the depth and pressure of the planet's atmosphere. But along with the science, New Horizons captured images that were eerily familiar.
Who would have thought that Pluto's atmosphere would be blue?
Although the physical processes are different, both Earth and Pluto have blue skies and complex atmospheres containing nitrogen. And, just like Earth, Pluto's atmosphere is dynamic and variable.
Well, Pluto has weather the same way, really, Earth has weather, or Mars has weather, or Titan has weather.
So Pluto is just like Earth in that it has a bunch of different weather and climate cycles. On Earth, we have the day-night cycle, and it gets warm during the day and cools off at night. Everything happens a lot faster on Earth because we're just closer to the sun. There's more energy, we go around faster. So the gusts here today are approaching 70 miles an hour. Actually, it would be very windy on Pluto too, especially around Sputnik Planitia. In the daytime, the ice sublimates and the wind blows out of the crater, and at night, that air cools down and flows back into the crater very violently. That's called a Catabatic Wind. So right around the edge of Sputnik Planitia is probably some of the windiest places on Pluto. It's where you would want to look if you wanted to look for dunes, for instance.
One reason some aspects of Pluto seem familiar is that many members of the science team had been studying small-scale phenomena that prepared them to understand this brand-new planet. Will Grundy and his colleagues on the science team, like Dale Cruikshank at NASA Ames, have been running lab experiments on the exotic ices known to be present on Pluto. They've found that radiation changes colorless ices such as nitrogen, methane, and carbon monoxide into yellows, reds, browns, and black.
There was never a time when I didn't think Pluto was going to be exciting. And the reason I was pretty confident about that was because I've played with the materials that are on the surface of Pluto, nitrogen ice, methane ice, carbon monoxide ice, in the laboratory at about that scale. And I've seen all kinds of weird phenomena going on in the laboratory. So I know these materials do interesting things. But what I lacked was the imagination of saying, grow that little sample, 1.5 centimeters across to the size of a planet. And what can it do? Holy moly, it can do a lot. And they can make just incredible landscapes. It's really the combinations of materials where the magic happens. But what we didn't, I think, really imagine was what just a wealth of landscapes it could make, and on such a grand scale.
As a person, what surprised me the most was how beautiful the landscapes are on Pluto, with twilight hazes and a blue sky and big ravines, gorgeous mountain ranges that have snow caps on them. And although there are craters on the surface, and you can certainly tell it's a faraway world, I don't think there's a more photogenic planet other than our own in the solar system.
But all this amazing new science would not have happened had not New Horizons engineers solved an anomaly that threatened the entire mission just 10 days before the triumphs of July 14th. Here's the human story of that anomaly and the recovery.
The Southern Cross Astronomical Society of Miami, Florida is proud to present the 2021 Winter Star Party Virtual Edition, February 8th through the 11th. Because of COVID, we will not be able to get together in person this year, but we won't let that stop us from getting together online with old friends and make some new ones. There will be all new presentations about double stars, astroarchaeology, Mars exploration, and more. Enjoy classic videos from past winter star parties by Tippy D'Oria, Dr. Mike Reynolds, John Dobson, and more. There will also be door prizes, but you have to register online by January 30th. To register, please visit www.scas.org. Go to the Winter Star Party tab. Select 2021 Virtual Winter Star Party from the drop-down menu. Go to the bottom of the page. Enter your name and email address and press register. And best of all, it's free. Then join us February 8th through the 11th from 7 to 11 p.m. Eastern Standard Time on www.explorescientific.com/Winter Star Party. Mark your calendar. See you there.